In this lesson, we will study about sequences and series. Now, you probably have studied this topic already, but we will understand the basics and we will look at some important concepts. I just want to give you a quick recap of what exactly is a sequence and how series are, and there are some of their properties. So let us get started. And I want to start with an example, actually two examples. Let's say I have a sequence. It's a sequence of numbers. So I have, say, 2, 4, 6, 8. This is my first example, and that's the sequence. And the second example is 2, 4, 10, 25, and so on. Now, before we talk any further, I want to make it very clear that this is a sequence. And this is not even a sequence. So I'll write down here, not a sequence. And this is a sequence. Now, I want you to understand what exactly a sequence is. When you say a sequence, the next number after 8 is predictable. You see there is a pattern here. Every number is 2 more than the previous number. So this has to be 10. You know the next number is going to be 12. So there is a predictability for all these numbers here. So we qualify them as a sequence. Whereas if you see here, you will never know what is the next number, right? Because there is no pattern. It's not predictable. And this is not a sequence. And we are not talking about anything that is not a sequence. So this is not something what we're discussing about. We will focus on sequences and we will study some of their properties. So let's go to the next page. See, when I say a sequence can be divided into two main types. The first one is called as arithmetic progression, and the other one is called as geometric progression. And let me give you an example of what an arithmetic progression, the short form is AP, and the geometric progression, GP, is all about. Let's take an example like 2, 4, 6, 8 is an AP. And on the contrary, let's say for example, it is 2, 4, 8, 16, 32, and so on is a geometric progression. So now, if you have to understand the key difference between the AP and GP, that is, here you will see that the difference between every two consecutive terms, the difference is 2. If you do 8 minus 6, 2, 6 minus 4, 2, 2 minus 4, 2. And even if you write the next number, which is 10, the difference is common. So we call this as a common difference, and common difference is denoted by D. And arithmetic progression will always have the difference, common difference D, same for all the numbers, any two consecutive numbers. Now, what happens in geometric progression is the ratio is common. So if you divide 32 by 16, you will get, that's 2, right? If you divide 16 by 8, it is still 2. So this is a common ratio. And these are the defining factors. So when you say a geometric progression, that automatically means that there is a R, which is a common ratio. And that's the standard notation. Now, there is one more thing these two things depend on, whether it is geometric or arithmetic progression. It depends on where it has started, where it starts. Like the first term really is the key, that tells you a lot about the sequence. And the first term is usually written as U1, or some places people say A for first term. Okay, we will mostly call it U1. Sometimes we call it A as well. It's the same thing. Whichever notation you want to use, that's no problem. Okay, so the arithmetic progression, just to quick recap, depends on D and U1. And arithmetic progression depends on the common ratio R and the first term U1, or you might want to call it A as well. Now, moving on, there are some formulae which are useful for AP and GP, both of them. I'm going to quickly write it down. You will find those formulae in your data booklet, so you don't have to memorize them, but it's always good to memorize them, so that you don't have to reach out to your data booklet every time you want to solve a problem. Very key, important formulae. Let's write it down. Now, this is the formula about nth term, and the second formula is sum of n terms. Sum of n terms. And let me first write down the formulae, and then we'll solve some sample questions so that you know how you use them. So nth term UN for an arithmetic progression, the formula is U1 plus n minus 1 times D. Okay, we will use this formula and solve a problem later on. And sum of n terms is written as n by 2. This is 2u1 plus n minus 1 times d. That is how you find sum of n terms. Similarly, I have got formula here for nth term of a GP, and the formula is un is equal to u1 r to the power n minus 1, and this is a sum of n terms, and we typically write this as Sn, S sub n. It is u1 r to the power n minus 1 over r minus 1, and this formula comes with the condition that r should not be 1, and that is quite obvious. If your r value is 1, then the denominator will simply become 0, and then S of n will become undefined. Now, this is just the basic. We give you the formula. Now, let us apply this formula and see how they work in action. So, I'm going to give you an example, right? And the example is, say, once again, 2, 4, 6, 8. For learning purposes, let's stick to this example itself. Now, the first term, u1, or you might want to call it a, is 2 over here. And the common difference d is a difference between any two consecutive term, and that is also 2. Now, guys, we have this as a first term. Sometimes we call this u1, second term u2, third term u3, u4, u5. Now, if I want to find sixth term, I'm sure you can do that by, using, the sixth term is 12. But let me see if our formula works. Now, if I want to find sixth term, that is written as u6, like u1 is the first term, u6 is the sixth term. Now, u6, we can use the formula. The formula was for AP, the formula of un was a plus n minus 1 times d. A is the first term, which is 2 plus n minus 1, that is 6 minus 1 times d is 2. So you solve and you'll get the value of u6 is equal to 2 plus, this is 10, and u6 is 12. I just want you to know the formula works. So this is the formula for nth term of an AP, and we just solved using that formula. I got the answer as well. Now, let's say if I want to find the sum of first 4 terms. Let's say I want to add all these terms. I want to find out the sum of these terms. Now, how do you solve that? Let's say sum of first 4 terms. And then that is sum for S for sum, and 4 terms. That's why it is S4. S4 is equal to, so we have a formula for Sn is n over 2. This is 2u1 plus n minus 1 times d. Let's use that formula. N is 4. So it is 4 over 2. This is 2 times u1. The first term is 2 plus n minus 1 is going to be 4 minus 1, 3. And d is 2, right? So you get S4 is equal to 2. And then 2 times 2 is 4. Then this is 3 times 2 is 6. And 6 plus 4 is 10 times 2 is 20. So is the sum of these terms 20? Just check. 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 is 20. So our Sn formula of AP is also working just fine, And of course, you can use this formula for finding sum of 100 terms, or let's say sum of any number of terms. So that is the advantage of these formulae. And these formulae will only work for arithmetic progression, which depends on the first term A and D, because everything really depends on that. And that is the example. Moving on, let's look at the second example I have here. The example here is, let's say 2, 4, 8, 16, 32, and so on. Now, if you look closely, you will see that the difference is not same. The difference here is just 2, but difference here is 4. Difference here is much more than that. So difference is not common. It's a ratio that is common. Okay, so we have u1 is equal to 2, and the common ratio r is the ratio of any two consecutive terms. So if you do 32 over 16, that's 2. The next term over the previous term, okay? And that is r, which is 2. Okay, so now once we find that, next, let's write down the formula, okay? The nth term formula is u1 r to the power n minus 1. That is the nth term of a GP. This is for GP, right? And for sum of n terms, this is Sn is equal to u1. This is r to the power n minus 1 over r minus 1. Condition is r should not be 1, and r is 2. So we can use this formula very well, no problem. Now let's just see how we find the third term. So if you want to find third term, then you can write u3. You will use this formula. Okay. U1, the first term is again 2, and then you have R is 2, and third term, so N is 3. 3 minus 1 is going to give me 2. So it is 2 times 4, and that is 8. Is it working? Absolutely. See, the third term is 8. Now let's look at, let's say, sum of first 4 terms. So sum of first 4 terms. Let's see how we do that. This is S4 is equal to U1 is 2. We'll use this formula. We know R is 2. 2 to the power N is 4 minus 1 over, this is 2 minus 1. And then you get the answer. 2 to the power 4 is 16. 16 minus 1 is 15. 15 times 2 is 30. And 2 minus 1, 30. And 2 minus 1 is just 1. So the answer is 30. S4 is 30. That is the sum of first 4 terms. So if I add all these terms together, I'll get 2 plus 4 is 6. 6 and 8 is 14. 14 and 16 is 13. Yes, it is working. So this is the second formula, right? So that's pretty much about it. The main 2 types of sequences are arithmetic progression and geometric progression. I solved a sample problem for each one of them so that you have an idea how you use the formulae. The key formulae of AP-GP are mentioned here. You can refer to them, available in the data booklet, but it's a good idea to remember them. This is pretty much the basics of sequences. That's all you need to know. Okay. And also in this chapter, I mentioned that there is something about series. Okay. So let me touch upon what a series is. Look, we already said that 2, 4, 6, 8, 10, 12 is a sequence, right? So this is a sequence. Now, simply, if I write 2 plus 4 plus 6 plus 8 plus 10 plus 12 and on and on and on, that's it. This is series. So it's very simply put, a series is nothing but sum of sequences. If you add all the values, all the terms of a sequence, you get series. Right? So that is the simple concept of series. We will definitely go in details of all these things. We will see some of the tricky questions. Okay. And we will see how this formula can be used. And this is just the introduction to the topic of sequence and series. In the next subsequent lessons, we will look at some of the questions, which will give you a good perspective on this chapter. So I see you in the next one.